Hey Algebra 2, here are your notes for lesson 6.6 and 6.8. And we've combined these lessons just because factoring polynomials and solving equations are from last semester, and we've already done a lot of work with those. The new thing today will be fundamental theorem of algebra. And don't freak out about the big scary name because it's really not that scary. It actually is really intuitive once you see why it's fundamental. So, like I said, most of this is review, but let's quick practice. So if I ask you to factor each of these polynomials completely, this first one, you should notice they all three have something in common. So we're going to start this one by factoring out a GCF, or a greatest common factor, which in this case is just x. When I remove an x, I'm left with x squared plus 10x plus 24. But as I said in our factoring unit, we always have to be careful that we can't break it down any further. And in this case, we can. This big parenthesis set can be broken down into xx, and of course bring that first x down. I think a 6 and a 4 will multiply to 24 and add to 10. So there is our factored version. And notice because it says factor, I don't have to solve this one. It's not set equal to 0. So this is my final answer. Same thing over here. The only way to factor this one is to pull out that GCF, which I notice they're both divisible by 5. I notice they both have y to the 4th, so I can bring that out of both of them. And I'm left with y squared, and then when I divide 125 by 5, I'm left with negative 25. Again, we can break this down further. If you notice, as you should, this is a difference of squares, which we always break down into the y minus 5 and y plus 5. You take the root of the first, it goes into the first two positions. You take the root of the second, it goes into the second two positions, and then we separate them with two different signs, the conjugates. And of course, don't forget to pull that 5y to the 4th down, because it's still part of our problem. There's your final answer. Shouldn't be too hard. All right, we've got one more. Again, they all have something in common. This is a GCF. All three of these have been GCF problems. They're all divisible by 8. They all have m cubed to give me. I'm left with m squared minus 2m plus 1. Of course, break it down further. A negative 1 and a negative 1 will multiply to a positive 1 and add to negative 2. Okay, and we're finished. We can't go any further. All right, and then let's just do a quick review of our special factoring patterns. So you should remember these. We did just talk about the difference of squares, but in case you don't remember what the formula is for that, when we have a difference of squares, we break it down into the two parentheses. And just like I said above, the square root of the first goes in the first two blanks. The square root of the second goes in the second two blanks. And then because there's a subtraction in the middle, we need to break them apart. These are called conjugates because they are the same, only differentiated by that middle sign. I would go ahead and circle this or maybe highlight it. This whole box is going to be really important. Just in case you have forgotten some of these, so I want you to use these on your homework. It'd be good to have these formulas nearby. All right, sum of two cubes. Remember, we can't do a sum of squares, but we can do a sum and difference of cubes, so we have a different equation for both of those. This one starts out as a plus b, and we have a squared minus ab plus b squared. So let's do a quick example of that. I have the equation right here. And for my sake, because I know I'm going to be working with a's and b's, and those are just the uncubed version of a cubed and b cubed, I like to write what my a and my b are. So in this case, the uncubed version of a is going to be 4x, because I took the cube root of 64, took the cube root of x cubed, and then b, the uncube of 1 is just 1. Once I have my a and b, then I can just plug it into my formula. I know this is a review for most of you. If you need to skip through this, I totally get it, but I do want to show it for those of you who haven't seen it in a while and you don't remember. 4x times 1 plus 1 squared. And here I'm just plugging in numbers. Now I'm going to take that extra step and simplify it. 4x plus 1, 16x squared minus 4x plus 1. And there is your final answer. Again, I'm going to show you all the steps here. You don't have to show those on your homework. All right, let's jump over to difference of two cubes. Same exact formula with slightly different signs. Instead of having a plus b at the beginning, I have a minus b. And then instead of having a minus sign inside of my second set, I just have plus signs. So plus ab plus b squared. And I hope you remember these formulas and that most of this is review, but if it's not, that's okay too. A and b. A in this case is 3x. B in this case is just a singular 2. I don't care about the minus sign because all the minus sign tells me is that it's a difference. The formula itself takes care of that for me. I don't really have to deal with making sure that my b is negative or positive. All right, let's plug it in. 3x minus 2, 3 squared x squared plus 3x times 2 plus 2 squared. Simplify that. 3x minus 2. 9x squared plus 6x plus 4. Just like that. There's your final answer. All right, let's check what's on the back. We've got two more here. Two more, examples of factoring, and then we're going to get to the fundamental theorem of algebra, which, again, sounds really crazy, but I'm so excited because it's so much more simple than it sounds. All right, factoring by grouping. If you remember, we look to see what things they have in common, and then we break it down the middle. We just factor out what these two have and factor out what these two have. Remember why we do that? These have a y squared. They're left with a 3y plus 1. If you factored by grouping correctly, you should see that whatever ends up in your first parentheses is also what ends up in your second parentheses. I'm going to factor out a positive 3 so that I'm left with 3y plus 1. I know I did this factoring right because I have the same thing in these two parentheses. And then grouping becomes the first thing plus the second thing, all multiplied by that second set of parentheses, because that is what the first term and the second term have in common. And then, of course, we can't break those down any further, so this is my final answer. All right, last example here, factoring polynomials in quadratic. They still follow all the same rules we've been talking about. You usually just have to take them one step further. So I'll tell you that I noticed this is a difference of squares right away. My a is 9x squared. My b is 4. So I'm going to put it in that difference of squares form. I'll do it over here. 9x squared plus 4 outside of 9x squared minus 4. Simple difference of squares formula. However, once I put it in this form, I should notice that this second set of parentheses is another difference of squares, which can be broken down further. I'm not going to write the a and b for this one, but if you need to, that's fine too. 3x goes in the first blank, 3x first blank, 2, 2, and then remember that minus sign indicates a conjugate, so I do a minus sign and a plus sign. And then, of course, bring down that first set of parentheses. Remember, we cannot simplify a sum of squares. We can only simplify a difference of squares. Maybe make a note of that for yourself on the previous page, because I see that mistake happening a lot. All right, we're finally there. The fundamental theorem of algebra. A polynomial equation of the form p of x equals 0 of degree n with complex coefficients has exactly n roots in the set of complex numbers. Here's the deal. All that means is that the highest degree on your variable, in this case this one has 5, all it means is that this equation is going to have exactly 5 solutions. Now we don't know if they're real or complex until we solve. However, we do know that 5 exist. So let's go ahead and take a look at why that's the case. Let's start factoring this down in order to solve it. First thing I'm going to notice, a GCF. Let's factor out an x. We're left with x to the 4th minus 15x squared minus 16, and it still equals 0. If I forget to write that, just remember that it's still there. We do still have to write it. This one looks really tricky, but I noticed that it's just a normal equation with higher powers. So this is still okay. I can do x squared and x squared. What multiplies to 16 and adds to 15? 16 and 1 will do it. Let's do negative 16 and positive 1. Now I notice that this is a sum of squares. I can't do anything with it, but I can break down my difference of squares right here. Of course, pulling down the x and the 0 as I usually do. This becomes x minus 4, x plus 4. This still comes down as x squared plus 1. And this is x. At this point, I can't break anything down further, so I have to use my zero product property. If you didn't remember that one, that says that when things are multiplied to equal 0, 1, 2, or all of those things could equal 0. Zero product property, that's what we're doing right here. All right, so my x could equal 0. That's a pretty simple one. X squared plus 1 could equal 0. Now when I solve this one, I'm going to get x squared equals negative 1. And when I take the square root of both sides, notice square root of negative 1, we should remember is what? It should be I. So I'm going to have x equals plus or minus I. And then the other two are pretty simple. X minus 4 equals 0. X plus 4 equals 0. I get answers there. So I'm going to line these up real quick in a different fashion to show you what we're talking about with the fundamental theorem of algebra. Let's move my page up. So I've got x equals 0. That's fine. I have x equals positive 4, x equals negative 4, and then I'm going to write out x equals positive I and x equals negative I. Now you remember what the fundamental theorem says. It says whatever your highest degree is, that's how many answers you have. And I said we don't know how many real we have until we do the problem. Well, you should notice after we've done the problem, we have 3 real answers. And then we have 2 complex. And I'm not going to call these imaginary because they could be numbers plus or minus I. I'm just going to say they're complex. So yeah, you can see that the fundamental theorem of algebra, the whole thing we've been working up to is this idea that we can take any equation and we can look at the solutions of it, whether they're real or not. All right, I want you to pause the video, see if you can break the next one down, and try and see if you can state the number and type of roots that that one has. Come on back when you're done, we'll check it out together. All right, hopefully you tried that one on your own. If you didn't, please do that now. All right, first thing you should notice with this one, it is a sum of cubes. So right away, I'm going to say my A and my B are x and 4, and then let's start setting up that equation. We have x plus 4 outside of x squared minus 4x plus 16. If I'm going a little fast for you, I'm sorry. I don't want these videos to be super long. If you need to see how to factor this one, go ahead and check the last page that we did for how to factor a sum of cubes. All right, I'm going to keep going here. I notice this one can't be broken down. However, because it has a squared here, I need a way to break it down. Bring back that quadratic formula, people. All right, this answer is eventually going to be useful to me, so don't forget about it, but right now we're just going to throw that quadratic formula out. X equals, and just for kicks, I'm going to write the equation out for those of you who don't remember it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I do have to resist the urge to sing, so if you could hear the tone in my voice, I apologize. All right, let's plug things in. Negative 4 becomes positive 4, plus or minus the square root. That becomes 16, minus 4 times 1 times 16, all over 2 times 1. I get two answers here. When I simplify this all the way down, it will be 4 plus or minus 4i root 3 all over 2. And then, of course, don't forget to bring this answer down. So I'm going to do my line again here just to show you what my full answers are. When I solve this one, I get x equals negative 4 as an answer. And then there's two answers hidden in here, so I'm going to write them both out, the negative and the positive. I get 4 plus 4i root 3 over 2. And I get x equals 4 minus 4i root 3 over 2. And let's indicate what those are. This one is a real, while these two are quite obviously complex. There's two of those, there's one real. All right, there it is. That is all. That is the fundamental theorem of algebra. You now know one of the most important theorems in algebra that there is. And I'm going to highlight this just to indicate that. All right, hopefully you have been practicing your factoring. If not and you have questions, don't hesitate to let me know.